10, 9, ignition sequence starts.
Look down. Look down. That fragile bubble of life floating on a sea of nothing.
It is often said that the first color images of the Earth from space inspired the ecological movement.
4, 3, 2, 1, top. Et décollage VS12.
5 decades later, satellite images of our planet have become essential for our survival.
Satellites in space give us different glasses, different ways to look at our planet Earth. If you look in the visible, you can see the clouds, and you can see the towns and the cities during the day. If you look in thermal infrared, you can look at the patterns of sea surface temperature as the ocean is moving. If you look in radar, then you're able to see surface roughness features. That gives us access to waves, to many, many different things, including how crops are developing during the growing season. And if you bring all of these together, then you start to get a big picture of how our planet is working. That's helpful for governments, for local authorities, for farmers, and even for people like you and I, because all of our data feeds into the weather forecast, and we use that every day to decide whether to go out. Altimetry is a very special set of measurements which gives us access to sea level, and we can monitor sea level rise, but it also gives us access to how the ocean's circulation works, because there are hills and bumps in the sea surface which correspond to the ocean circulation. So by understanding planet Earth through measurements, we're able to provide evidence of change. Today, with the European Copernicus program, we have a fleet of operational spacecraft providing those different colors of our planet Earth.
These satellites scan the surface of the planet in order to provide accurate information for changes in sea level. But to achieve such accuracy, their instruments need to be calibrated constantly from fixed points on the Earth's surface. To do so, new techniques had to be developed. This challenge was taken up by a professor of engineering working on the Greek island of Crete.
It's an ideal location because we see different satellites crossing at the same point. So that was the impetus, the beginning of this project.
Working together with the European Space Agency, Professor Mερτίκας and his team developed a unique system of interconnected devices for the calibration of satellites. Its central feature is a prototype mechanism called the transponder.
It's as if the transponder is another satellite on the Earth.
This growing network of devices has been used to calibrate satellites that pass over Crete for the last decade. But now, the system is being upgraded.
We have a new satellite, Sentinel-6 Michael Freilich, and here we're implementing a synthetic aperture radar altimeter, which is dedicated to making measurements of sea level rise. We piloted those techniques to get better resolution on the ground. Now, in order to know how good our measurements are, we need to make measurements on ground.
As the new satellite takes over from its predecessor, longtime collaborators Stέλιος Μερτίκας and Graig Donlon meet on the south coast of Crete. But their final destination is a small island on the very edge of Europe. legend has it that Gavdos was the home of the nymph Calypso, who fell in love with Ulysses and kept him prisoner for 7 years. Today, with just a handful of permanent residents and little infrastructure, the only way to reach Gavdos is by boat. Despite these difficulties, however, it was chosen as the site for a new improved version of the original transponder.
The location here is very strategic because Gavdos has another 3 satellites crossing that location at ascending and descending orbits. So we can actually compare if the results are the same. Here it is.
Wow! Stelios, it's fantastic! I can see a lot of changes here.
The new facility here has the ability to calibrate the antennas and make them exactly parallel so they see the satellite exactly at the same point. We don't want any distance in between transmission and reception.
So Stelios, the satellite transmits a radar pulse,
Yes.
which is received by this antenna.
Exactly.
And goes into the box where it's analyzed and amplified.
Yes.
And then it's retransmitted back to the satellite here.
Yes. The key here is that we know exactly the time it took from the time it arrived at this antenna until it's been transmitted back to the satellite.
And that time is?
Nanoseconds.
It's very challenging because the satellite flies at 1,330 kilometers, 1,330 kilometers in space. If we have just one measurement, we're never sure if it's the good measurement. So there's many people working on those aspects, and we've been really trying hard to get ready for today.
It's the first day today that we have an actual measurement of the tandem mission of Jason 3 and Sentinel-6.
Are you worried?
Always.
The Sentinel-6 Michael Freilich satellite launched on the 21st of November 2020 from California in order to replace its predecessor, Jason 3. But first, the 2 satellites must fly together and jointly calibrate their instruments by sending a signal. First on the transponder on the mountain, and then 9 seconds later to the new one in Gavdos. For the team on the ground, this is a make or break moment.
Okay, anytime now. Yay, well done, fantastic.
Congratulations.
Oh, congratulations. Fantastic. Everybody was so happy when the light came on and the buzzer came on. So at least you know this time we got the satellite. So we got both, Jason first and then Sentinel-6.
It's really good news that you managed to get past and after all that hard work.
Thanks for all your help as well, and look forward to working on the data later today.
Whatever we produce has 3 objectives. One is that we secure the quality of the scientific measurements we produce. We give people the right information about climate change, and we help the policymakers to decide the right policy in terms of the climate change.
For every 1 centimeter of sea level rise, we can expect a displacement of 2 to 3 million people. By the time we reach 2050, we can expect 20 to 30 centimeters of sea level rise globally. We may even have up to 1 meter or even 2 meters by 2100. That is inundation and that is lost land. If we think about the 600 or so million people that live in coastal regions around the world, this is an enormous number of people. Their livelihoods, their communities, their cities, the very fabric of life is ripped apart as they have to relocate. So understanding the quality of the measurement is extremely important. What will happen with our future? What will climate change bring? What will the actions of my government mean for today's society? What do I need to do?